When you've been given a function like this one, the first shift theorem we understand, in the first shift theorem we understand that it always takes this kind of a form, the Laplace transform of our function exponential at we multiply by our function f of t. Here is a positive or a negative is equals to, we first find the Laplace transform of our function f of t, and then to the term of s we come and shift directly, to mean that when we are having here a positive, here we are going to have a negative, and when we are having here a negative, to the term of s that will be shifted, we are going to have a positive. By finding the Laplace transform of our function here, we cannot find the Laplace transform of sine squared t, to mean that we rewrite sine squared t into another form, and by rewriting sine squared t into another form, we are going to have sine squared t is equals to a half into 1 we subtract from cos 2t. This is how we are going to rewrite sine squared t. And now we are going to have 3. We find the Laplace transform of exponential negative a half t. Sine squared t is going to be equals to a half into 1 we subtract from cos 2t. Let us now factor out a half and open our bracket. By factoring out a half, we are going to have 3 all over 2. We get the Laplace transform of, we open the bracket, exponential negative a half t. We subtract from exponential negative a half t cos 2t. From this point now, we can do the Laplace transform of our exponential and use the first shift theorem in solving our function here. By finding the Laplace transform of our function here, we are going to have 3 all over 2 into, here we do not have a function f of t, so we are going to find its Laplace transform directly, and we are going to have 1 all over s. We add to a half, because we understand that the Laplace transform of exponential positive or negative at is equals to 1 all over s negative or positive of a. That is the Laplace transform of exponential at, and that is the reason as to why when you check here the coefficient of t, it is a negative of a half. Here now we must have a positive. We come and now add to the Laplace transform of our functions on this side. Here now we are going to use the first shift theorem. We agreed that when it comes to the first shift theorem, it is going to be the Laplace transform of our function f of t, which is equals to cos 2t, which is going to be s all over s squared we add to 2 squared, which is equals to 4. By using the first shift theorem, it is only the term of s that has been shifted with respect to a, to mean that we are now going to have the term of s being shifted. We are going to have s, it is a negative, to mean that here we are going to take a positive. Negative is down, positive is down here to the term of s. So we are going to have a positive of a half, because that is the term of a all over, that is on the numerator, all over s. We do our shifting. Everything was squared. And then we come and add to 4. Let us now simplify our fractions here. And by simplification of these fractions, they can be quite challenging, but we are going to go through each and every step. When we are having this fraction and this fraction, we can rewrite them. And by rewriting this fraction into its improper, now we are going to have 3 all over 2. We multiply by 1 all over. Here we are going to have s, we 2s, we take 2, we multiply by this one, we are going to have 2s, we add 2, 1, everything will be all over 2. We take the denominators, we multiply them together. We come and get the improper, we come and add 2. Whatever we are having here is equals to whatever we are having here. So we are going to have s, 2s, we add to 1, we add to 1 all over 2. Everything is going to be all over. We can open our bracket here. And by opening this bracket now, we understand that we are having s, we add to a half. We come and multiply by s, we add to a half. To mean that we are going to have s squared, we add to s squared, s multiplied by this one, multiplied by 2, we are going to have s, we are going to add to 1 all over 4, we add to 4. From this point, let us now work out with the improper fractions. And by working out with the improper fractions, we are going to have 3 all over 2 into, here we are going to have 2 all over 2 as we add to 1. We come and add 2. Here we are going to have this fraction here, we are going to have s squared, we add to s, we add to, here we are going to have 17 all over 4. When we do away with our denominator here, we are going to have 4 all over 4s, we add s squared, we add to 4s, we add to 17. Everything is all over 4. That is how we can go about this fraction. To mean that now, this is what we are going to have here on our denominator. So here we are going to have 2s, we add to 1 all over 2, everything is going to be all over 4s squared, we add to 4s, we add to 17, everything is now going to be all over 4. Let us now simplify our improper fractions on that side, and now we are going to have 3 all over 2 into 2 all over 2 as we add to 1. We come and add 2, here we are supposed to be having the negatives. Because I forgot about that negative at this point. To mean that now here we are going to have 2 as we add to 1 all over 2. This improper fraction, the fraction on the denominator, now we are going to multiply by 4 all over 4 s squared, we add to 4 as we add to 17. That is how you are going to go about this improper fraction here. 2 is going to cancel out here, this 2 is going to cancel out there. These two can cancel here, one, these two cancel there, it cancel there. So we are going to have 3 into 1 all over 2 as we add to 1. We come and add to 2 as we add to 1 all over 4s squared we add to 4 as we add to 17. Here we are supposed to be having a negative. I keep on forgetting about the negative, sorry for that. Now from this point now, we take this bracket, we multiply by this bracket here. We take whatever we are having here, we multiply by 1 here, and then we multiply our denominator. That is how we are going to simplify our fraction here. By simplifying our fractions here, we are going to have 3 into 1 we multiply by 4s squared. We add to 4s, we add to 17. We come and subtract from 2 as we add to 1, we multiply by 2 as we add to 1. Everything will be all over 2 as we add to 1, we multiply by 4s squared we add to 4 as we add to 17. On the numerator, we are going to have 3 into 4s squared we add to 4 as we add to 17. We subtract from 4s squared. We add to 2 as we add to 2 as we add to 1. All over our denominator 2 as we add to 1 into 4s squared we add to 4 as we add to 17. Here we are going to have 3 into 4s squared. We add to 4 as we add to 17. We subtract from 4s squared, we subtract from 4s, we subtract from 1. Everything is going to be all over 2s we add to 1 into 4s squared we add to 4s we add to 17. Positive, negative, these two are going to cancel out. Positive, negative, these two are going to cancel out. Here we are going to have 16. 3 into 2 as we add to 1 into 4s squared we add to 4 as we add to 17. 3 multiplied by that, we are going to have 48 all over 2 as we add to 1 into 4s squared we add to 4 as we add to 17. And now this is our answer on this question using the first shift theorem, and this is how you simplify the fractions. Let us now find the Laplace transform of our function here, whereby when you've been given a function like this, using the first shift theorem, we understand we are going to have the Laplace transform of exponential at, positive or negative, of a function f of t is equals to f, the Laplace transform of a function s, f, s, we subtract or add to a to the term of s, to mean that we shift our term of s with respect to a. When you've been given a function like this one, the first thing that we need to understand is that we cannot find the Laplace transform of this function directly. To mean that, we are going to simplify it. And by simplifying this function here, we are going to have now, we understand that 2 cos squared t is equals to 1 we add to cos 2t. Since we are only having cos squared t, we divide by 2. On this side also we divide by 2. And we are going now to have cos squared t is equals to a half into 1 we add to cos 2t. To mean that we've already simplified our function f of t at this point. Now we are going to have a half. We find the Laplace transform of exponential 3t into a half. Here we come and multiply by 1 we add to cos 2t. We can factor out a half here, and we are going to have 1 over 4. The Laplace transform of exponential 3t. We open the bracket, we come and add to exponential 3t cos 2t. Everything we get its Laplace transform. Here we are going to find the Laplace transform of this function of our exponential directly, because we do not have a function f of t. But here we are having our function f of t. The Laplace transform of our function here is going to be a quarter. We multiply by 1 all over s. We subtract from 3. Because we know that if you've been told to find the Laplace transform of exponential positive or negative at, this one is equals to 1 all over s. We subtract from or add to a. When we are having a negative coefficient of a, here we are going to have a positive. And when we are having a positive here, here we are going to take a negative. So when it comes to this one, here we are having a positive of 3t. To mean that s is going to be on the denominator, we must get to be a negative. Here there is no shifting. We come and add 2. This is now where we are going to carry out our shifting, because the formula says it is the exponential, a function f of t. After finding the Laplace transform of our function f of t, we shift with respect to s. Let us now get here. We understand that we get the Laplace transform of cos 2t. That is what we are being required to do here. We first get the Laplace transform of cos 2t. And finding the Laplace transform of cos 2t, we are going to have s all over s squared we add to 4, because a is going to be squared. We come and now get the shifting or to the term of s, because it is the Laplace transform of a function t, of our function t, into the term of s. We do our shifting. We're going to have s, but here we are having a positive of 3. We say that when it is a positive here, the coefficient of t is a positive here. On this side, we are going to have a negative. To mean that here now we are going to have s. We subtract from 3, because this is what we refer to as the shifting. All over, here we are now going to have s. It was s squared. We do our shifting, 3 It is only the term of s that we shift, and here now we are going to have an addition of 4, the way we were having it just there. Let us now continue with our working, and here now we are going to have a quarter into 1 all over s. We subtract from 3. We come and add to s. We subtract from 3 all over. Here we can open our bracket and we are going to have s squared. We subtract from s multiplied by 3. A negative of 3 we multiply by 2. That is factorization. We are going to have 6s. We add to 9. We come and add to 4. Here I've only simplified what we are having here. And by doing that, now we are going to have, here now we can have 13, a total of 13, because it is a positive of 9, we add to 4. So here we are going to have a total of 13. Let us now open our brackets here by simplifying our two fractions. And now we are going to have, we take whatever we are having here, we multiply by 1. Whatever we are having here, we multiply by this bracket, and then we take the denominators, we multiply together. And by doing that, we are going to have a quarter into 1, we multiply by s squared. We subtract from 6s, we add to 13. We come and add to s, we subtract from 3, we multiply by s, we subtract from 3. All over our denominators, s we subtract from 3 into s squared, we subtract from 6s, we add to 13. 1 all over 4, a quarter. On our numerator, we are going to have s squared, we subtract from 6s, we add to 13. Our first bracket, we come and add to, here we are going to have s squared, we subtract from 6, we subtract from 6s, because we are going to take, we subtract from 3s, we subtract from 3s, we add to 9. On our denominator, we are going to have s, we subtract from 3 into s squared, we subtract from 6s, we add to 13. 1 all over 4 into, on our numerator, we are going to have s squared, we subtract from 6s, we add to 13. We add to s squared, we subtract from 6s, we add to 9. Everything is going to be all over s, we subtract from 3 into s squared, we subtract from 6s, we add to 13. A quarter into, here now, s we add to s, we are going to have 2s squared, negative 6, we add to a negative of 6, we are going to have a negative of 12s, and here now we are going to have 22. we add to 22. Everything will be all over s we subtract from 3 into s squared we subtract from 6x s we add to 13. Goes here 1, here we are going to factor out 2, and now we are going to have a half into s squared we subtract from 6s we add to 11 all over s we subtract from 3 we come and multiply by s squared we subtract from 6s we add to 13. And this is how you go about simplification of this function using the first shift theorem.